Hello everyone. We are live now. Welcome. We'll wait still like 2 or 3 minutes for everyone to be able to join. Good morning. So everyone have a chance because sometimes there have some issues. And in a few minutes we'll begin our webinar.
Hello everyone.
Hello
Good
everyone.
morning.
Good morning. You can post a comment if you wish. Where you're from which country, continent, would be nice. We broadcast from Warsaw, Poland, but I guess some of you might be in different regions, different time zones. Let's see. Yeah, how's the weather? Yeah, hello from Finland.
But today seems to be improving. There is
Yeah.
again kind of blue sky and
Snowstorm.
sun. So let's see.
Yeah,
That was a very weird beginning of spring. No?
yeah, exactly. Everyone was expecting to have a spring already in the beginning of of the month, and now this snowstorm came in the weekend. Now it's getting better. Even the snow already melted. In my surrounding at last. So yeah.
Yes. But it's a lot of wind also, and it's gonna be rain throughout the week.
Yeah, unfortunately. Okay, let's wait 1 more minute and we'll begin. Cloudy. Okay, everyone, I guess it's time to begin. We have like 11, 11, so it's okay. Welcome everyone on our webinar. It's Peter or Piotr in Polish, and I am Victor today. We have a pleasure for you to talk about machine learning solutions in AWS Cloud. We'll show you how to begin with machine learning in the scenario where you already have some technical knowledge about building the models and stuff like this, but also in a scenario when you don't have any, let's say, deep knowledge and you don't want to build your own machine learning team in your company. So we touch both scenarios in our presentation. Welcome everyone. My name is Piotr Kalinowski. I just wanted to tell them I'm from Cloud State Company or Chmurowisko in Polish, but we have, let's say, both names. I work as a data and AI engineer, working in the cloud. So I mostly work with, only work in cloud projects that touches AWS or sometimes Azure, depends on the client. And I help them to, let's say, use data that they collect so they can get some more value from this data using some, let's say, classical tools or using machine learning or deep learning sometimes. Depends on what they need. And today I want to very warmly welcome Victor, who is AWS personal service guy from AWS. Victor, if you can introduce yourself, it would be nice.
Yeah. Hello everyone. Thank you for attending today to our webinar. As Piotr said, my name is Victor Jaramillo. I am located in Warsaw in Poland, and I am a data science consultant in the professional services team, which is like consultant teams that AWS has to help different customers to move to the cloud, right? So I am not developing things for AWS itself, right? But I'm helping the customers to move to the cloud.
Yeah, thank you very much, Victor. Yeah, so basically you have two cloud guys that want to show you something today. So I guess we can just begin, Victor, right?
Sure.
Yeah.
Sure.
You can
so
share the
start.
presentation. And
I have some presentation.
I will change. Yeah. So now everyone should see two pretty faces at the left, and the main screen you have a presentation. So let's begin.
Okay. So this is our presentation for today. Our plan for today is to give a brief talk about let's say AI/ML related services and machine learning in AWS, and then to do a couple of demos of how you can enable machine learning AI using Amazon SageMaker, right? So as many of you realize, in the recent years, like the reach of machine learning is growing. We see it all the time. Sometimes it's annoying because, you know, I feel like there is too much hype, but also on the other hand, more and more companies are really finding out that there is real value in AI ML if you know how to exploit it, right? So there is definitely an increase in spending in companies, right? As consultant in AWS, I can tell you that nowadays, the majority of projects, when I jump into companies, are related not machine learning itself, but ML ops, in the sense that most of big companies already have data scientist teams that are building their models. So it shows that many companies, at least the biggest companies, are really mature in this regard and are definitely spending more, right? And like it's here in the middle, we are transitioning from pilots to operationalization of the machine learning itself, right? Because nowadays, most of the projects are like ML ops related, because what happened is that companies had lots of data scientist teams, that they were creating lots of models, but they didn't know how to put the models in production, how to put a model in a server, how to have a versioning control of the models, versioning control of the scripts that create the models, and so on. So this also shows, right, like how ML is growing and is becoming more mature, right? And also there is a AI transformation in the sense that many organizations are really using AI heavily to transform in the way in which they operate, to base the decisions more on data than on general assumptions or, let's say, rough numbers, right? Now they can really exploit all the data that they accumulated over the years. So I don't know, many of you may wonder what is really machine learning? Why sometimes we say deep learning? Why sometimes we say artificial intelligence or deep learning, right? So AI, let's say, is the general concept that embodies all the others. And in general, in artificial intelligence, there is many sub-concepts, techniques, etc. But right now, let's define it as it says here. It's any technique that enables computer to make human intelligence using logic, if-then statements, and machine learning, including deep learning, right? So machine learning is a subset of artificial intelligence that uses machines to search for patterns in data to be able to build logic models automatically, right? And inside machine learning, we have deep learning, right? That is a subset of machine learning that is composed of deeply multi-layered neural networks. In the past, they were like they called shallow neural networks because they had the so-called hidden layers where only like one or two. But now with deep learning, we have many layers, right? In the order of tens or hundreds of layers. So the deep learning models are massive, and they were not possible before in the past, like 20 years ago, because the computers were not powerful enough for that. So that's why in the recent years we have been seen an increase in the interest in deep learning, because also it has shown that it has a lot of capabilities, for example, for image recognition and for natural language processing. Now, within Amazon itself, we are also exploiting the capabilities of AI and ML, right? If you ever use Amazon services or AWS services, well, you can see examples of that in like a simple recommendation engine that you can see in on Amazon, right? It shows you the products that based on your purchases from the past, show you new products. This is AI in the back, right? The fulfillment centers also use AI ML for predicting, for forecasting the stock, forecasting demand. So all the optimization that the fulfillment centers need uses AI ML. Alexa, well, Alexa itself is an example of natural language processing, right? It's really understanding our speech and is able to translate it and to understand the context and the intention of what we are saying. And also the first prime air, like the how we are enabling like the delivery of packagings by air, right? The drones here in Poland, I think it's available even in Europe. But it's just one of the examples, right, of innovation at scale in Amazon. Now, jumping into our AI ML stack in AWS, I wanted to touch several topics because like to clarify, like sometimes when people hear Amazon SageMaker, they think that SageMaker is just the Jupyter notebooks, or that let's say AI ML in Amazon or in AWS, sorry, is Jupyter notebooks. But actually, there is a wide variety of things. Now, Piotr will continue. He will start talking about a few of the services.
Yeah. So I really like this slide. It takes different forms. You can see the same, let's say, content in different, let's say, design. But the main idea is really nice that in the cloud, in the AWS, we have, let's say, a few layers of different AI and ML services. So we are not going to go deep in every of these services that you can see here because there are too many of them. But you can see the general pattern, right? It's going from the bottom of this slide. We have services like, I don't know, simple EC2, or for example, FPGA, GPU, infrastructure services that helps you, that allows you to build your ML models, that gives you just the let's say infrastructure. But you can go higher. You can all use ML services like SageMaker that we're going to go talk through deeply in a few seconds, and build your model from scratch, or using the libraries that already are there. Or even you can go even higher and you can use something which is called AI services. And this is pretty nice because basically you can use the machine learning models that are already trained by the AWS people, by the really smart guys who know how to build this model. So basically they took, for example, let's take, I don't know, Amazon recognition service, which is the most, I think, popular example of such say AI service. So this Amazon recognition allows you to take a photo and, for example, the algorithm tells you what is on this photo. I mean, if you can see a car, or bicycle, if it's a landscape, I don't know, are there any words? What are the words? So it's kind of OCR, but more intelligent. It can also analyze videos as well. So basically, what people from AWS did, they took a bunch of open data sets with many photos, many videos, yeah, and they trained in the cloud the large models that now you can use as a service. So it's like kind of model as a service, right? So you can just use this ready to use model. You can just take your own photos and just using Amazon recognition, you can can get information what's on this photo, right? And there are all these services are specialized for, let's say, specific scenario. You know Amazon recognition, I talked about it. For example, you have, for example, Amazon Polly, which is basically speech to text and text-to-speech service, right? So it uses machine learning models to transform your text into the artificial speech, for example. I don't know, let's take, Amazon Kendra, which is a really nice service because it's a search service and it can search many different sources, databases, I don't know, documents, etc., and put it into, let's say, one place. Or I don't know, Amazon Translate, right? That helps use machine learning models to translate between languages. It can even translate on the fly, right? From what we are saying, you can use the translation services, these Amazon Translates, to translate on the fly what you are talking in the real time. So it's really nice idea. And these services already, let's say, they contain models that are trained. You just can use it. You pay as you go for this. So basically, as much as you use this model, you pay for as much as you use. And it's really nice, right? So it's kind of model as a service bunch of capabilities that AWS gives you. Now, Victor, please let's talk more about the SageMaker because it's more, let's say, sophisticated service for training the models.
Yeah, thank you, Piotr. So yes, like Piotr said, like we saw in the top, we have a higher level services where you are not required to train your models, right? You are using models out that AWS is providing you, and sometimes you just need to use the console to upload data, etc. But in the ML services part is where, let's say, a more machine learning capable teams can work, right? Because here's where you have you are offered some tools and infrastructure to enable you to create your own models. So SageMaker itself is not only Jupyter notebooks. There are multiple other services, like we see here, like we have the processing jobs, right? When you have to prepare your data. So instead of running the preparation scripts in a, I don't know, in an ad hoc EC2 instance, well, you can define your script, the type of instance you want, and you can launch your preprocessing jobs and at the scale you want, right? You can launch, you can reach the limits of AWS to launch, I don't know, 10, 100, 200 preprocessing jobs when you have to prepare like high volumes of data, for example. We have also feature store, which is embedded into the SageMaker Studio. We have the bias detection tool, which is the Amazon Clarify. We have the notebooks themselves. We have training instances, right? Which is pretty cool because sometimes when you are training models in a, let's say let's say you launch a Jupyter notebook, sometimes you can reach, let's say, the physical limits of your instance, right? You are occupying all the RAM, or your model is taking too long because the instance is not very powerful. Well, then you can use training instances. So what you do is that you define what type of instance you want. I don't know, multi-GPU, massive instance, and you can have terabytes of data coming in and train your model, right? And you don't have to worry about it. Everything is managed in the back by AWS. So you just need to define the configuration and launch it. In the same way, if you need to schedule trainings or retrainings of models, it also works like that. And you don't have to provision EC2 instances. You don't have to worry about patches, about updating stuff. Everything is managed for you. We have also capabilities to do hyper tuning, right? You just define the range of parameters and which parameters you want to run, and you trigger your hyper tuning jobs, and this will run in the back the same way, right? There are also good things that it keeps traceability of all the experiments you do, the performance of your models, and in the end, well, and you can have different policies of how to decide which of the different experiments or hyper tuning jobs was the best, right? Also, we have capabilities to deploy models, right? Take a model that was trained in a training job and put it in an endpoint. The same way, you don't have to worry about configuring your server to serve requests, etc. No, you just need to give the server what is your model, and the server will take care of the rest, right? This is pretty cool. For example, when you have a model that is in production and you want to update your model, you don't have to manage automatically this blue-green deployments, and you worry that your users will see a timeout of your service or something like that. No, SageMaker takes care of deploying the new models by itself. This is pretty good. And also we have the sprint predictions, right? Like with the Clarify, there is also like a feature of explainability, so you can use an embedded shop library within AWS, and it can help you to understand what were the predictions of the model. Last but not least, we have the model monitoring, which is also a tool very, very useful when you want to keep track of how your model is performing, right? So here we have the whole spectrum of the services, and is more specialized, like we said. But when we have teams that are ML capable, this definitely enables them into being more productive and focusing on, let's say, the data science itself, and leaving all these other things related with infrastructure to AWS.
Yeah.
So
sorry for interrupting.
Sorry,
if you can go back one
you wanted
slide.
To say something?
Yeah. I just wanted to say that very often that's a pattern that I observe with many clients. If the clients, for example, they have an idea to use the ML for something, right, for improving their business, and basically they don't know if it will succeed, because we don't know very often at the beginning. So first, they use these AI services to, let's say, try machine learning, to try if these models that are ready to use will improve their business somehow. If yes, then they, let's say, build a team of data scientists, which builds the model using the, for example, SageMaker, which is more, let's say, sophisticated, more specialized. And at the end, they transfer from these AI services into more specialized another SageMaker model. It's a very, let's say, very common pattern for many clients. They transfer in this way. Also, another example how clients use this, they sometimes mixed, let's say, to these components. So, for example, for one of my clients, we built the application with the model using SageMaker that was used for classifying the photos. So there was an application on your phone. You took a photo from your application, and the SageMaker model told you if this photo is photo of something of category A, B, C, or D. Let's call it like this. And it was built using SageMaker, right? But also we wanted to introduce, let's say, previous layer that will tell if this photo makes sense. It's not a trash photo. If it's not a photo taken by accident of anything, right? So for this, we use Amazon Recognition just to tell us if this photo is, let's say, eligible for classification in the model. So we, let's say, combine these two approaches. We use both recognition and both, let's say, more sophisticated SageMaker model in order to, and we combine them in one application to work with for the client. Just to give you two examples of how these services were used in let's say, real life scenarios. We have more of them in a few slides. Okay, Victor, sorry.
Okay, thanks. So now, like after this, let's say, technical bit, I think one of the main discussions often is like, what is the real impact of AI/ML, right, in organizations? Because sometimes people say, I would like to use AI/ML, but I don't know what for, or I don't know if it's really needed. So here, like a brief example, like you can find out new revenue streams, right? You can find out that improving certain parts of your process can help you get some revenue from other elements that you were not considering before. Improve the efficiency of your operations, right? Optimizing the resources, the allocation of resources, or, for example, detect and respond to business risks. One example I can tell you from a customer, I will not say the name, it's just a customer we have. This customer was asking us, like, if we could use AI/ML to detect when their customers were having some kind of emergency situations, because they were making more requests to the to the customer, right? Like for supporting some things that they were doing. So we noticed in the historical values of different customers of the customer that indeed sometimes there were some spikes, and that in the past the account managers knew that there was something going on. So we had a kind of labeled data, and with some AIML, we managed to identify that with the model, we could detect when the customers of our customer had emergencies. And the idea was that if they knew that there was very likely an emergency going on, the customer could reach out and offer additional services for auditing, for controlling, etc., that normally will not be offered, right? Because it's unnecessary. So it was a very interesting, let's say, example to show like you can grow your revenue stream in this specific, let's say, service that you were offering, just by detecting when your customer might need it more specifically, and then you can direct your account managers to go there and offer it, etc. So that was very good, right? In general, like this was just one example, but AWS or AIML in general, not AWS, can impact businesses in every field that you can imagine. Like we have clients from them, customers from many different fields, right? Like in the healthcare, we have, for example, AstraZeneca. Industrial manufacturing, I can tell you we are currently working with Volkswagen, for example. Financial services, we have many banks, and like in the projects that I'm telling, like the customers I'm telling are customers that I know that we have worked with, and they are actively using AIML, right? Retail, Amazon itself, right, is heavily using AIML in the retail websites. Media and entertainment, there is Discovery Channel that we will see a use case in a couple of slides afterwards. So typically, this is like how or in which specific aspects like AIML can intervene depending on what you are looking for, right? So for example, if you are looking for enhancing customer experience, well, AIML can help you to build chatbots or virtual assistants to speed up the process, like to identify what your customer is asking about and then redirect the customer request to a human that can respond faster in a specific aspect, right? Intelligent contact centers that are optimized with regards to how to direct the requests of the customers, personalization, for example, the recommender systems, right? And other aspect is like the better and faster decision making, right? We can see an example here of fraud prevention that is typically used in the financial markets, forecasting as well, use of warehouses for Amazon, for example, forecasts demand of the product, etc. Anomaly detection typically used not only, let's say, for factories or production, but also when you have a social media website or a e-commerce, when you notice some weird traffic or weird patterns in traffic or sales, etc. It can help you identify problems. Now, thinking about how to improve business operations, well, demand, like I was saying before, right? The predictive maintenance, quality control and visual inspection, right? And finally, when you need to create new services, it can also help you because you can exploit all the data you have to find out new things. So for example, like you say here, autonomous services, the health, AI in health are typical examples of this. Now we have, here are like a few examples, and in a moment we will talk more about the use cases. Like Intuit, it uses AIML for their data centers, right? It helps them to identify better like the patterns of the calls, to allocate the resources properly depending on the time of the day and the locations, right? 3M is also using AIML for Kendra, for the search engines inside the company. Like Piotr was saying before, Kendra is a very powerful search engine for the documents. When you have, let's say, a company, an existing database of hundreds of documents with all the documentation related to your internal processes, etc., Kendra can build, let's say, the search engine to find out information in all these documents by itself. Koch Industries is using AI/ML for predictive maintenance, right? And the NFL, I don't know if you've seen it, like in the same way as for the Bundesliga, there are AWS is being used to leverage AI/ML technologies to predict, let's say, the outcome of a match, to reveal the statistics during the match, etc. So it's pretty cool because it improves the user experience when watching the game, right? Here's a brief example of few of our customers. Here we are going to take from few examples from here and in the use cases in a moment, but this is just to show you, right? There is a massive amount of customers that are using AWS, and not only AWS, but AI/ML itself. So it shows that the real value of moving into this direction, right? And in the sense that, well, AWS is not only offering them the solutions in cloud, but it's also addressing the customer challenges. And when, for example, we as Proserve, we are we have lots of experience, or if not us, also members of our teams or other organizations. We have a lot of documented use cases and things that, let's say, we build a know-how that we can help the customers to improve how they are doing their business in themselves, how to enable the usage of AI/ML into their clouds. So now this is something that we will do later. In the demo today, the idea is to show you how to do a training, right? Sorry, I confused the slide. These are the things that within AWS, you can enable your teams to go through all these steps and become, let's say, proficient in the uses of AWS. We have trainings, right? There are trainings that can be offered by AWS trainers themselves. I think Kumurovisko is one of them, right? Also, there is a lot of online resources where you can learn. You can also have access to this ML Solutions Lab or the AWS ML Embark program. Whenever you have a company that has, I don't know, you have a specific use case that you would like to test, you can reach out to AWS. And depending on your, I don't know, if the company qualifies, they can help you to access the solution lab. And so you can come up with your ideation and improve your, come up with the proof of concept of your idea using AI/ML, right? And from there, well, then you can learn how to really exploit the AWS services to leverage your idea and ultimately build your own model, right? And move out to a production or a MVP. So now I will go through some use cases, and then Piotr will also talk about them.
Yeah.
Please, Piotr, remember to share, if you can, the links.
Yeah. I will pass the link on chat to the use cases websites while Victor will talk about them in details.
Yes. So here we have this the use case with the New York Times, right? The business need was that they wanted to build a digital-first customer care function that meets the needs of their digital subscribers. Existing systems were siloed and data was structured and unstructured, right? This is a very typical issue. Teams are siloed, like isolated, right? So the solution was to replace their telephony system with Amazon Connect and Amazon Contact Lens to generate transcripts and identify important customer experience indicators that they combine with information from other channels like email and Amazon Lex chatbots. And they also use Amazon Comprehend to automatically tag the interactions. Ultimately, the impact was they managed to build a very rich data model that gave them the key insights about what customers were contacting them about with 90% of accuracy, right? And they use all these insights to help their development teams add feature changes and bug fixes. So this is a pretty good example, right? Like when you really have to, get used to, in some kind of the people say, no, this is how we are doing it always and it works. But sometimes, there are always ways to improve things. And I think this is a good example with that. Ryanair, also there was an example with them, like they wanted to offer 24/7 access to the customer support. So they built this multi-channel, multilingual chatbot platform that is using Amazon Lex and SageMaker to optimize the responses to the customers, and uses Amazon Comprehend to provide sentiment analysis. So you can see here in their case, it was more focus. There was a more focus on higher level services, right? However, well, it doesn't mean that the solution is less worthy in the other hand, right? The impact was that they since they launched it in 2018, this chatbot managed to handle over 3 million conversations, supports English, Italian, French, Spanish, and German. This is like the EU5 languages. And it became like a real true extension for the customer service team, right? So this is also a very important point here, right? Sometimes the solutions that are built on top of AI/ML are not only focused on, it's not focusing on replacing the people, but supporting what people do, right? Which I believe is the main purpose in the end. This one is the discovery, like I commented before, right, on the entertainment side. They wanted to build a flexible and scalable content recommendation system to go fast, as fast as possible to the market, right? So they use Amazon Personalized and create personalized content experiences for customers on the Discovery Plus streaming platform. In the end, well, they managed to improve the customer experience. They went went to target in a very tight amount of time, and now the solution is working with their current infrastructure. So Piotr, now if you want to continue talking.
Yeah. So first use case from my side is pretty classical. It's Domino's Pizza, basically. Let me also apply the link to the case study. So it's a company that delivers pizza for sure, and they already had a large amount of data collected in their data lake. They want to use it somehow. They have information about who ordered pizza, from which part of the city, what type of pizza, and so on, how much time the delivery took. And then they just built a simple model SageMaker, and simple, but the SageMaker model that allows them to reduce the pizza delivery time. So they optimized the way how they deliver pizza, how they, let's say, divide work between pizza delivery guys, which part of the city they should, let's say, handle, deliver pizza as effectively as they can. And also, let's say the second result, they enable fast and easy deployment of new franchises of the Domino's Pizza. So if someone wanted to open the Domino's Pizza, it was much easier after this, let's say, implementation of this model. Let's go next.
Yes.
We have a 3M company. Let me as well paste the link here on the chat. Yeah, so basically 3M is a large company. They have many data that was spread around different data sources, databases, different, I know, document stores, some documentations, I know, even some things like SharePoint or something like this. And they use this Amazon Kendra, which is, we talked about it in a couple of minutes ago, which is like really powerful, extensive search engine for almost everything. And they, let's say, use this in order to enable to use natural language processing, natural language queries to search everything they had, right? Everything, all these documents, all this content that they produce, they were able to search it using Kendra. And basically, it allows you to find certain pieces of information, certain documents, articles much faster than previously. And it was easier to, let's say, move around all this data that they had stored in different places. Okay, let's go next. Someone was asking about medical or, let's say, health use case. So this is Astra Zeneca, known mostly from the COVID vaccination, but not only. I pressed the link, two links. So basically, they used most of them SageMaker Groundproof. SageMaker Groundproof is a service for data labeling, right? So if you have like a lot of data, Groundproof allows you to label your data. For example, I know you have a pictures or pictures, right? It allows you to easily label your data based on, I know, picture category, what's in the picture, and so on, right? And then you can build a model that, for example, analyze the pictures and tell you what's on the picture, what is the category of this picture, how you should categorize it, basically. So they increase the, for example, human spend cataloging samples, right? So they let's say, instead of someone who was cataloging the samples, they use the machine, they use the cameras, and they were doing it automatically faster and basically faster, more efficient. That's more important. And let's go to the last one, which is basically a Hyundai company. I also placed the link here. It's very nice. I like this use case because here AWS allows Hyundai to say work for autonomous driving. So they wanted to, they needed to build an autonomous car, and they use this SageMaker service, SageMaker models to build such model that allows everyone to use the Hyundai to drive autonomously on the street. And it's really nice use case. I like it because you can even play it yourself using the AWS Deep Racer service, which allows you to build your own car. Or maybe you have a car, but you can build your own model using the car, and you have like a small model of autonomous car that you can drive on your whenever in your flat, right? Or something like this. It's really nice use case, and for sure, autonomous driving is, let's say, something that is really hot nowadays. So yeah.
Okay. So that's it from our presentation side. If you have more questions, I think you can post them in the chat, and we will try to answer them later on.
Yeah.
I think now we can move on to our demo.
Mm-hmm. Yeah, good idea.
Okay, so let me minimize here. Let me close this chat so I don't get messages. So the content that we are going to see today, is here, is the Amazon SageMaker Immersion Day. I think you can share the link for this, Piotr.
I'll try in a second. Give me a second. I'll just take it.
Yeah. So these immersion days are, let's say, workshop contents that you can either do it with the AWS instructor or all do it by yourself, right? Of course, you will need an AWS account, and but everything is indicated of how to do it. So in the prerequisites, we are required, if we are doing it by ourselves, we are required to configure things related with, first of all, we have to launch the SageMaker Studio. SageMaker Studio, like for those who don't know it, is like IDE for AI/ML related things in AWS. So it's very interesting because in a single place, you can have access to most of the AI/ML related services in the SageMaker. Let's say ML services, not AI, in the sense that we are not using here directly Amazon Kendra or TextRack, things like that, but we are using the ML services related with the training, data preparation, hosting, deployment, etc. So the studio has access to all of them. I will show you in a second. And well, you have to launch the studio, and for that you have to make some go through this menu. Is very simple, right? You just need to submit and approve. The role is created automatically for you, and then you can launch the studio domain, right? You can have one studio domain per region per account, and after that you can launch an app, and it opens the SageMaker Studio, right? After that, you need to launch a Jupyter notebook inside the studio, and in the notebook, well, you can either do it in the notebook or do it in a terminal, right? In the same way you can here, for example, once you are in studio, if you are here, like this is the topical menu, you can either come here and click on terminal or come to file, new, system terminal, right? The terminal. So you launch the terminal and then you clone this repository and it will download the materials that you are going to use, we are going to use today for the immersion day. So I did already this, right? I git clone it and I download this folder.
Interrupt, maybe you can enlarge a little bit.
Sure.
Yeah, great.
Okay, so it downloads this folder, right? And this folder has all the materials for the immersion day. And immersion day has all these labs. Today we are not going to go through all of them. This is long, but you can continue doing it by yourselves later on. So the first lab is about feature engineering, right? Here we have an example of our machine learning process, right? First of all, one of the most important things is when before I start with the machine learning, I have to understand the business problem and then understand how I can frame this within ML. Because sometimes people think that they want to solve something with machine learning, but sometimes it's not possible or not necessary, right? Like it happened that we had a customer that wanted, I don't know, this person saw, I don't know, a workshop, some video about reinforcement learning, right? And then this person decided, I want to use it in my company. I want to predict the forecast of some products. And then, well, he reached out to us. He said, I want reinforcement learning for this. And then we were asking, okay, so what is the data? Yes, it's here. I said, but for reinforcement learning, you need a very specific data set, right? And you need to have, like, let's say, iteration loops in your decision processes, like when you're making human decisions, because this is part of the things that the model will use to learn and to improve. But turns out that the data points were very minimal. So in the end, it could not be solved with reinforcement learning, right? And the person was obsessed that it had to be done like that. So it took a big of effort to understand this. And this is a typical problem. So be careful. Not everything should be or could be resolved by machine learning. Sometimes simpler approaches work. So this is a very important element here. So after we have this, here we start with the typical process, right? Like we have data collection, we need our data, we can integrate their data. If we have different data sources, we have to prepare it and clean it, right? To organize it and make it set up everything properly for our model. We can then analyze it and visualize to see there are not anomalies or weird things going on. And then we can extract the features that are the ones that we are going to use later on for our training. So in this step of the feature engineering is where AWS, let's say, can help you to some extent. A few other things here, let's say, are not explicitly related with SageMaker, but in the feature engineering or here, we can help you. And how? Well, here are three alternatives in which you could do the feature engineering or data processing or data you have. One is to use the data wrangler, which is like an automatic tool for this, but we are not going to touch these tools right now. The other one is NumPy and Pandas. Let's say if you want to process your data manually in the Jupyter notebook inside the here. I'm sorry, sometimes I talk about Jupyter notebook, like if everybody knows. If you are not familiar, Jupyter notebooks are like it looks like a notepad. But the good thing of this is that it allows you to execute Python code in individual cells, right? So I can have one cell like this and I can run the code here without going to a terminal and typing the Python and the name of my script, right? I can have individual executions. And this is typically used in data science and machine learning for data analysis, training models, etc., right? So let's continue here. So we are going to use the SageMaker processing jobs to be able to see how it works, and then to process our data. So first of all, we need to launch this Jupyter notebook, the Processing XGBoost and IPy notebook, right? I already launched it, and let's go here. So it is a file, Processing XGBoost, and this is what it opens. So this is an example of that is a data set for marketing, like targeting direct marketing with Amazon SageMaker XGBoost. And in this example, we will see how we can use processing jobs to process the data. So what I need to do, well, I need to execute my cells. It's imports the libraries, defines in which bucket, S3 bucket, I'm going to store my data or to retrieve it. Sometimes it's already stored there. Here we load the libraries that we are going to use, right? The data, we get it from this location. It's already in a AWS bucket that is public, so you can download it. I already downloaded into the notebook itself. Then here we can visualize it, right? This is the type of data that we have, like of the marketing campaigns, right? So we have a lot of people in which I guess the marketing was applied, and there was a outcome, right? Yes or no, if the marketing campaign worked, like if we engage the person. The idea now is like every training that you run or training or processing that you run in AWS, you need to store the data in S3, right? Why? Because if you have a notebook, yeah, it can be that you can have here a small data set, but if you have gigabytes of data, to store them in a notebook sometimes is not practical, right? Or feasible also, because there are some restrictions in where the data has to be hosted, etc. So by default, everything has to be stored in S3. So here we take the file that we already downloaded and downloaded and upload it to S3 in this particular location, right? It's in this bucket, SageMaker. We can have a look there and verify that the bucket is still there. Sorry a second. I think it expired. Yes. So let me again go very quickly to the account, because I wanted to show you that the data is already there. That we managed to push it there without going manually to the bucket, right? Only from our commands in the notebook, we managed to put the data there. So it's global. Oh, what? Perhaps I click in the wrong account. I'm sorry. Has to be that I clicked in the wrong account. 3744. I'm sorry. This is yes. I sorry. My apologies. I log into the wrong account, so that's why you don't see the bucket there. Let me log out quickly. Is yes, it's this one. So if we go to S3, here we should see our bucket, and here is the data for the mentioned day. But this is one script, and here we have the data set. Yes, it's a CSV. So the good thing of this, like I was saying about preprocessing or in AWS, is that you can run your data preprocessing, feature engineering in the SageMaker. You don't need to go instantiate an EC2 instance and then put the data, process it, etc. No, you just need to define what is your script for processing the data, what is your data what you want to process, and then you define a container. Like you can use predefined containers that Amazon already has, and you can schedule, for example, preprocessing, or you can configure it in a way that if your data arrives to S3, it triggers the preprocessing automatically, so you don't have to set up anything manually, right? So here is our preprocessing script, right? This is the preprocessing script. Is written in this way, so this can be called from the command line interface within the processing job, right? So this is basically what we are doing. We are using pandas to process our data. What we do here, we define where is the data that is going to be used for the processing job. And this is other paths used for the training job later on. Here, we define it's an object, right, for our processing. So we are using scikit-learn library, and we just tell like in which kind of instance I want the preprocessing to run, how many instances, right? I don't have to go and launch them manually. I can just do it from here. And before running this processor, right? Like this is the processor where I define the object itself. Here, before running it, I configured it. I say, okay, look, the code that you're going to run is this preprocessing script that I defined before. The input data is in this specific location inside the container, but outside is in the input source. If we input source is an S3 location where our data is, right? And in the same way, the output, there's inside the container this is the location, right? And in the let's say in reality afterwards, the finish is train path. After the processing of the data finishes, the result is stored here, right? And it's stored here because then we use it from here to train the job. So then we can execute this cell, and this starts the preprocessing job, right? So if we go to the here, let's go to SageMaker. Amazon SageMaker. We can see that the processing job started there. Yes, there is one processing job in progress, right? We are running the processing job. And here is like all the configuration that we saw before is here as well. So this is very good because also it keeps traceability of what your team does or what you do. So you can always know what happened. In the end, we will see our data in this path, right? This is we will find out that there is this CSV file, right? After, well, one thing I wanted to show you quickly. When you're launching these training jobs, you typically, processing jobs, sorry, you typically are, let's say, offer many different types of instances that you can run. Like typically, you use the standard instances, right? Unless you have a specific needs. So, for example, in some cases, your data sets are very heavy and you're using pandas or some other library that needs more RAM because it's like loading the data set and in memory. So you could use, for example, the memory optimized data set instances that for the same CPUs have like more RAM memory, right? Or if for some reason it's more compute intensive, you can use compute optimized. And last but not least, if you, for your processing, you need the GPUs, you can also use GPU instances, right? And that have, of course, like graphics cards, but for AI ML. Now, there is no list, but we have also a new generation. Now, the latest generation is the G5, right? That uses the latest NVIDIA chips. It's also much powerful. And yeah, it's like I know that there's a lot of options, but in the end, like it depends a lot of what you really want to do. If you are doing general stuff, you can use the standard instances and just have a look to the memory or to your budget, right? So let's go back to the processing job. I think it should be done in a second. The idea was just here, you just check that the data is here, right? Because then we can use it for our training. Now, for training the models, once you have your data, you need to define a training container, right? AWS has defined lots of containers that are ready for you to use. In this case, because we are using XGBoost, we are using the XGBoost containers, right, that are ready, available for us. And in the version, we can just put latest if we don't care. We want the latest version always, right? So this is an important element, because what the SageMaker needs to be able to launch a training for you is that it needs to know what is the training container, where is the input data, where is the output data going to be located, and if necessary, any training script that you use to pre-process your data or to do something before running the training itself. So you can also inject the script, right? So these are the say 4 elements that you need. And like we see here, all these are being defined. Like first of all, we define the container. We have the input data location, the validation location, which is also useful if you want to analyze after you train the model, how your model perform, right? And do the validation. And here, let's say the estimator that is used later for the training is defined, and at the end is launched as a feed. So first of all, you define the estimator, like I said, with the container. The role, which is your AWS user role or the AWS role used for trainings, etc. It depends on how your organization controls the accessibility. Instance count, you can have multiple instances. For example, if you want to run train things in parallel, like we saw before in the use case of Hyundai, they were using GPUs, multiple instance GPU training jobs to train things in parallel and to speed up the process of training. So you can also do it here. In this case, we have like typical general purpose instance, an M4. We define where we want the data to be stored, and the SageMaker session, right? Which is like the session we create to like instantiate the training job. We can also set hyperparameters. And at the end, you just need to launch the training job saying what is your input data and your validation data, right? And it inherits these. Very cool thing here is that also you can parameterize all of these. So like I was also commenting before, you can, thanks to that, you can run hyper-tuning jobs, right? And you don't have to worry about occupying your instance, your server, etc. No, it's in managed instances that you just need to click and they get the training going. So I think our processing job here finished. Yes, it finished here. We just can inspect where the data is. It's in the train path. Like we were saying before, it's in a stream. So if I now launch the training job, let's have a look. Container. Yes, let's see if we can launch the training job again. Yes, it's starting the training job. So here, let's close here. We can go to training jobs, and in progress. Here we can see that the training job is in progress. So now many of you can say, but yeah, I don't need these training jobs if I can run the trainings by myself in a Jupyter notebook. Yeah, the thing is that sometimes when you are putting the models in production, you don't want to do this manually yourself, right? If every month you want to retrain your model because you have more data, so you want to retrain it again, you can easily set up an automation pipeline to run the retrainings for you, right? And this is when it's useful to have these training job instances. Also, if you are using very heavy models, for example, natural language processing models like the ones from Hugging Face, this can take hours to train. So if you don't want to just occupy your computer because you're running training jobs or take a lot of time because your computer is not powerful enough, you can just launch a training job in a massive instance or in a parallel approach with multiple instances as well, and speed up your training processes. So this is where mostly AWS shines, when you're running things at scale, right? If you are like an individual doing small things, probably you don't see the capabilities, but when you start to scale up is when you really see the need to use a bigger infrastructure, right? So this training job is running in the back. I also run the hosting. The hosting is just that we put the model in an endpoint. And here it is. No, sorry, it's here. So you see the model is basically in a server waiting for requests for predictions of, like the model is itself here. And I can send requests of, we can, wait a second, I can stop here. We can send requests to see what the model predicts. right? So for example, in this case, there is a small script created for that, in which I am making the predictions, right? The predict here. Let me see. I want to see. Yeah, in the model itself, predictions, predict, receives. Here splits the data. Is it? Yes, here. So predictor, predict array. This is where we are. The predictor is the object from before, like this XSGBoost predictor, right? We are passing it as the predictor itself, and we are passing the array of data, and it's giving us the request back. So if we send this, it sends me the predictions is the output. And here we can plot, right? So you can either send one request of like group them in one single batch and send many like data points for request the predictions. So this what actually happened right now, not with a model that is inside this notebook, but is the model that is already hosted here in this SageMaker inference endpoint, right? It's a shame like we don't see this in real time. It has like a 5 minutes. It's logging the data every 5 minutes, so we could see like every time we send a request, we should see spikes right on the predictions logs, right? We show us, but that was we don't need to see those details, right? It's really not strictly necessary. The important thing was to see this, right? And in the same way, when I predict and when I deploy this, I don't have to do it manually, right? I don't have to insert an easy to instance, put my model there, and then request predictions. I can just use the capabilities of AWS to automatically host my models, right? Update them automatically, and guarantee that they are always on, that they are always available, and that everything is traceable and everything is logged, right? Without me going to configure things manually, set up logging mechanisms in EC2 instances, patch the EC2 instance, etc. Everything is, let's say, managed by AWS. So I think that's all from me. I'm sorry, I think I consume a bit of the time. I don't know if you have any questions, please make them in the chat. I think like now I will stop sharing my screen and I will give the control back to Piotr.
Thank you, Victor. Thank you very much. So I will take the screen for last short demo for you. Okay, so basically we told you at the beginning that these AI services, maybe higher level, are more for people who, let's say, don't want to train their own model. They just want to use it. SageMaker is more for people who have more, let's say, technical knowledge about training the model and they know how to train it efficiently. But it's not really true. I mean, there's also a feature in SageMaker which is called the autopilot. And it's basically really nice because it allows you to train your model without any machine learning technical knowledge. You just take the data, tell the SageMaker, train the model on this data, and it's doing this, right? Without anything, right? So I want to show you quickly how it works. Basically, this is a piece of notebook, but this notebook just downloads the data set. Just that the data set. It's the same data set as Victor showed you. So it's basically this marketing data set that you have. And one thing that I did here, the lab did, at last, it just uploads this data to S3. So you have a trained dataset CSV on S3 in the directory, and you have a test data for testing the algorithm. And that's all right now. So basically, we begin with the training data on S3. We want to now train the model. And you have two options. We can use the notebooks. We can use the SageMaker API to train the model, right, which is described here. But now I want to show you the easiest way that you can imagine. So basically, you just create a new autopilot experiment. You type the experiment name, so I don't know, web exp autopilot, whatever. You point to the data, right? I point to the S3 location, which is already here, right? This is this trained data in CSV that I uploaded to the S3, right? I select the target column, which is basically I say what I want to predict. In this case, I want to predict Y column. Y column tells if the if someone from this data set should be, let's say, targeted for the marketing or not. That's simply yes or not. So I target this column, and I want to. I also here I also can set the machine learning problem type, which I want to, let's say, solve. It can be automatically chosen by the SageMaker, but it's a binary classification. But I can also choose auto, and I also can choose, and not this, but here, how many candidates it should choose, because how autopilot works under the hood. It basically takes a bunch of models with different hyperparameter values, and it just tries different models with different these hyperparameter values, right? So as a result, it will output you different models with different hyperparameter values with different results. So it's this model, I know, binary tree with these hyperparameter values gives you accuracy of, I know, 0.7, for example, right? And you get a list of these models. Here, you can choose how many models you want to train, different, right? For the demo, I won't even launch it because it will take a few minutes and we don't have time for launching it. I'll launch it, so I'll show you the results. But you can choose how many candidates you have, right? For the demo, I launched for 5, because it for faster compute time. And just run it, create experiment, and it's running, right? It will take some time for computing different models, machine learning models, and you see the result. Okay, also you need to put the direct output location, right? And now I can. And here's the result, right? I want to run this one. You can see here, I just have a result that was run right 14 hours ago before this webinar. So here I have like 5 models. One of them is the best. So yeah, 5 different models that was with different accuracy. You can see the best one is 0.866. So pretty good as a machine learning problem. I didn't tune any model. I didn't tune anything. I just used the autopilot. Just give me the model, and that's all, right? And it gives really promising results. To be honest, I also once tried autopilot on the Kaggle. Perhaps you know the Kaggle website. Is a website with machine learning competitions, so you can take part in machine learning competition. And I just take part in one of the competition. I just took the data set, put into autopilot, and I got one of the I don't know 20% best score in the, let's say, all the Kaggle competition, right, from all the world. So it's really promising without any data processing, preprocessing, anything like this, data cleaning, and so on. So here I get the model. I can easily deploy the model, right? It's easy. It's really easy. I just create an endpoint name, demo, like this. I tell what the instance type of my deployment model that I will deploy, a number of instances, and that's all. I can just deploy the model. Of course, it takes some time to deploy because you need to set up an instance under the hood. But what is nice, what I really like about this, that this deployment gives me automatically. It gives me the URL of the endpoint, and I can just use the URL, right? So here I have the SageMaker window as well. Here I have my models that you saw. Here's my model that I trained yesterday, which is this one. This is the model, right? It's stored in this repository, and also here I have endpoints, right? Here's my endpoint. It's in service, right? The new one's creating, but let's not wait for him. This one is in service. Here I get the URL. So basically, I can just invoke this URL. I need just to make a simple REST API post call to this endpoint with parameters that I want to predict, and I will get the result. It's so simple, right? I get everything. I don't need to configure anything else. I just click deploy model, and it's deployed. really nice. Another thing that I can do here, I can use the batch transform, and this basically, because the endpoint, like here, is mostly for real-time predictions, right? So I can imagine I have an application that in the real time uses this endpoint to make some predictions for me, for my customer, whatever, right? But also I can use batch transform, which is basically creating a prediction for the batch jobs, right? So I can create a new batch transform job. Just type a job name, sample job. Right, I choose the model that I want to use. So I basically take this model that I trained. Right, choose the instance type that I want to use for this batch transforming, number of instances. And I need to also point to my data, because basically I will take the batch of my data from S3, right? And I will predict for every of these, let's say, sample in S3, I will just predict the value with my model, right? So here I need to point to the S3 data location, and it's this test data, right? So this test data doesn't have information about the outcome of our model. It's just the data. I can copy this, paste it here, and also post a location to the output date, right? So I can take here and some output. That's quite everything, right? And that's all. And I just type create job, and this will take all these samples from this test data CSV. Sorry, this one, and try to predict for every of the record. Try to predict is the outcome of the model, right? I did it already, so you don't need to wait. It's done here. It's completed. As a result, the result is in the here in this S3 directory. Yeah, I have a CSV file. I have opened it here. Sorry, in VS Code. Yeah. So here you can see that I just got a bunch of yes or no, right? So the trained data is information about the client, and here I just get the information if the client is eligible for targeting, for marketing, right? Yes, no, yes, no. So these are the results, right? That's the idea. Of course, check the accuracy, whatever I need. So what I wanted to show you in these few, let's say, screens here, that we can use SageMaker very effectively without any machine learning knowledge. We can use the autopilot, which will allow you to just train the model, right? Without choosing the model, the algorithm, without choosing the happy parameters. That's the first thing. And then you can easily deploy this model to an endpoint and use it in our application, right? Without any sophisticated, I don't know, development skills or technical skills. I just clicked everything from the AWS console. Yeah, that's all that I can tell you right now. So these are the demos. You have a link to these labs. I pasted on the chat. I can paste it again in a few seconds. We encourage you to continue with this for sure. So you can play with it and see how many possibilities these tools have, because it's really a lot of stuff, I would say. And it's time for questions. So if you want, you can feel free to ask questions. We have already asked one question that I want to show. It's really very good question, and that I really like it. So I leave it for the end of this presentation. So maybe I can begin, and Victor, if you know, you can elaborate later. So what is the psychological barrier of people to overcome when implementing AI in organization? It's a really good question, because to be honest, personally myself, I encountered this issue in one of the clients. When we, let's say, come with the ready-to-use model, machine learning model for some let's say, image recognition, and they were people in this company who did this job like manually. They were just kind of, let's say, sorting things, right? They were looking at something and sorting. And now we bring them a model that was sorting these things automatically for them. And it's a very psychological barrier because these people were simply afraid of losing their job. It's just simple, right? Because they were afraid that some IT guys will come and steal their job, right? They will introduce the AI and they won't be able to work. They will just be fired because the computer will do their job instead of them. So this is a barrier. It's not really true that it's like this. So to be honest, the history ended up that this customer introduced this model and no one was fired, hopefully. And the answer is that for this, let's say, issue, that artificial intelligence and machine learning, it's not designed for firing people, for replacing them, but it's rather for helping them in their everyday job and everyday duties, right? So basically, this machine learning model helps them to be more effective, right? To work better, to be more effective, simply, right? Not to in order to fire the people and telling them that they need to change the job because now the computers will steal this job. So this is one of the large psychological barrier. Some people understand that it's not a really issue, that computers are not for stealing the job, but many of them are still afraid of such AI solutions, and they're simply afraid of such scenarios. So this is one of things that needs to be overcome. Victor, any thoughts about this?
Yes, one of the things that well, you touched one of the topics is that people is afraid that they will get their jobs like removed, right? I think like there is certain truth there, because it's like the same thing like in industrial automation. Industrial automation typically replaces jobs that are, let's say, not so valuable in the sense that are repetitive and let's say exhausting, physically exhausting, etc. So the problem is that sometimes people have to change also their minds in the sense that we have to specialize ourselves, right? And that's in that thing we should not be afraid of automation. Of course, this is not it's easier said than done. So one thing, let's say, this is, let's say, one of the side of the spectrum when trying to push for AI ML innovation in a company. There is another side of the spectrum, let's say the managers, because people is like, we are used to do the things in this way, we don't need that, we don't need AI ML, etc. I think that those persons can have, let's say, a mentality of, we always did it like that in this way, it always worked like that. To be able to beat this barrier, I think that we will have to work, let's say, on our own, trying to build a small use case in which we can show the manager or the person of interest, a stakeholder, like, look, with the AML, I built this model, we are predicting this, and we are solving this problem, or we are optimizing this bit of the process. So I think that was the only way to convince them, to show them the results, probably in a pilot or in a side project, right? Otherwise, it's very difficult. Or I don't know, it can be that pushing the person to go to conference and stuff, right? Typically happens like that, like when your employees told you this should be done, you don't care. But if someone abroad from outside tells you, yes, yeah, they told me. Yeah. Typically happens like that, like with your friends or with your parents. If your parents tell you something, you don't care. But if your friend tells you, yes, it's the best, right? So probably similar situation. So I think that might be the case, right? Like the fear of change and the like the people don't want to be challenged sometimes. Like, for example, a manager can say, no, I always make the best decisions. So if you tell the person, look, you can improve what you do with the AML, and say, well, what does it mean? You mean that something can give better results than me, right? This, for example, was a case with the X-ray technologies when it was discovered, the X-rays, and when they tried to push this into the medical practice, that was a huge problem, because in those times doctors were highly respected, and that touching the things, yeah, you have this problem, you have broken bone here, like, doctors can do very obvious things, right? But when you have internal problems, it's very difficult to identify. So the X-ray was challenging them, and that was a whole process. It took like 10 years for the X-ray to become mainstream in the market. So I think this is the similar thing that can happen with AIML, right?
Yeah, that's right. That's right. We have a question about workshops that you can suggest me for processing medical images. Let's show it. The images for sure. I don't know if they're medical. Do you have anything, Victor?
No, I have. Well, I don't know if you can share this content that we have right now, these examples for workshops, because I think like in the end, what you need to have is label data and and the knowledge of how to set up your training. So even if you don't have medical images, if you have I don't know, this ImageNet or COCO data sets for image recognition, I think what you can learn training models to detect objects or to identify images is also very useful once you have to translate this knowledge to medical images.
Mm-hmm.
I think medical images are more complicated because typically this involves personal information.
Yeah.
And so I don't know if it's that easy to find open source samples of medical images that you can use.
Exactly. We have also one more question.
So do you have an example of AI implementation where model was constantly trained by people based on their assessment of AI outcomes? Mm-hmm. So this is like kind of human in the loop.
Yeah.
I never had this kind of situation. What I did is that I was working in a startup where we had e-commerce. No, it was a fintech. We were lending money to Amazon sellers. So what happened at the beginning? They had very basic models that they created basically in Excel, based on people from financial and risk analysis. They had some kind of rules, right? So they created the models in Excel. This is how the startup started, literally. So then they built the models, and what they were doing, they were validating that the model was giving similar outcomes as their manual processes. And this is, let's say, how they started to trust their first machine learning models. So I believe that, well, in the end, you always need to do backtesting, right? You have a first data set or a initial sample that you know is your ground truth and is certain. You always need to do backtest. If you have a new version of the model, you have to validate it with that old data to see if it still matches that reality, right? In this case of lending, it was very important to do the backtesting. So I think like probably for jump starting the projects, it can happen. I had this example, for example, in in fintech. And but I think once you start to train the model, you really don't need to involve people there. Perhaps sometimes for I don't know, like data audits or model quality assessment, you can involve someone to analyze the outcome of the model and then tell, hey, the model is working weird. However, there are many model monitoring methods and with statistical analysis in which you can automatically calculate things and just have a look at a dashboard and see if some KPIs drop or something. You can say something's wrong with the model. Right? You don't need to involve someone to analyze the data manually.
Yeah. I want to also emphasize that it's not like this that you train a model once and you have it ready. I mean, it's a rare case. Rather, have a life cycle that you train a model, you use it, then you collect more data, you retrain the model, and you collect more data, retrain the model, right? So it's like a kind of living, let's say, creature, the model. is constantly improving, and in most scenarios, there's a team that is, let's say, taking care of this model and retraining it, redeploying. So it's not one time shot, but it's something that is constantly changing.
Yeah. One point is this is a good point for you, Piotr, is that when we think about machine learning, people seem to think about a model. When you build machine learning things, your final product is not a model, but the whole infrastructure around the model, data monitoring, model monitoring, retraining pipeline, quality assessment, like all these things. Because if you create a model and you put it in a server, this is going to be a very poor solution. Because
Yeah, right.
like Werner Vogel says, things fail all the time, prepare for failure. You have to be prepared that at some moment your model will start to drift and its performance will slow down. So you need to have strategies to be able to overcome this and retrain it and keep the performance up to the levels you need. So that's the important thing. Like when you're building machine learning models, you're not only building the model, you're building the whole infrastructure around it.
Yeah, that's right. So I think we have time for one more question, and we'll go to the end soon, because the time's up already. So if you want to ask someone, feel free. If not, if there are no more questions, I think we can, Victor, wrap it up. Thank you, everyone, for attending, for joining our webinar. Hope you enjoyed. You'll get some summary from us after via the email. So you have some links, useful links for you. Yeah, thank you very much. Wish you good luck in your machine learning way. One more, please. There is still one more question someone to ask.
So yeah, go on.
Yeah.
If the last question.
Someone don't want to ask now, you want to have, you will have our emails, so you can ask via emails. So last question, what would be the team structure for a machine learning project?
It depends. If you're in a startup, you can have one person that does everything. One person is data engineer, data scientist, machine learning engineer. If you're in a big organization with lots of money, let's say you can have 3 persons. One is in charge of data engineering, one data scientist, and one machine learning engineer. But I believe that these are the 3 roles that define it's a machine learning team, right? Someone who go on. Sorry, Piotr. Yeah.
There's also, let's say, some of the companies also, let's say, defined role of MLOps, which is more of specialized DevOps, and also.
Yeah, this is like what I feel that the machine learning engineer fits, right? That the machine learning engineer knows a bit of data science, but also knows a lot of DevOps and software engineering, so knows how to put the models in production, how to set up the CI/CD pipelines, etc. So I think this is the minimum, the MVP of roles. But it can be that only one person is doing everything. It's not excelling at everything, but can do and set up and put things to run. If not, well, probably 2 3 people, like data scientist, data engineer, and machine learning engineer, or vice versa, or overlaps between these three different roles. Yeah.
Okay, guys, thank you very much then.
Okay. Thank you, everyone.
Thank you. Bye.
Bye-bye.